advantage. Okay, permutations and combinations. You guys would have read this chapter. I'm going to show you a couple things from the chapter and then a couple things that aren't in the chapter, and that'll be today. So when you think of a permutation, does anybody remember the difference between a permutation and combination? How do you keep them straight? Permutation, combination. Anybody remember? Okay, so this is important because some things are permutations and some things are combinations. The permutation, it's a specific order. So when the order matters, it's a permutation. And in real life, it's going to be a word problem, Frozen. So in real life, this is going to be a word problem. You know, you're not going to have the capital P in the notation in real life. It's going to be a word problem. And so you'll have to figure out, does the order matter? If the order matters, it's a permutation. If the order does not matter, just how many groups can we make, then it's a combination. So if you remember, the first number to the left in this format is the total number of objects. The total number of objects. And then the bottom right is the number in each group. The number in each group. So the bottom left, total number of objects. The bottom right, the amount in each group. So the first example here, we have 7 total objects, and we're going to use all 7 in the group. So how many different groups can we make where the order matters? So you can think about it. You got 1 through 7. Just switch the last 2, you have a whole second group, right? Switch the last 3, you got another group. And then you can still switch the last 3 and another group and the last 3 and the last 3 and then 4, and all those different groups you can make with different orders. Well, whenever the total number of objects equals those used in the group, meaning you use all the objects, the quick way to do this is it's just factorial. Do you guys remember what factorial is? Right? 7 times 6 times 5 times 4 times 3 times 2. You have a button on your calculator, just punch in 7 factorial. It'll be an exclamation mark is the factorial button. Sometimes X, exclamation mark, or just the exclamation mark. And a lot of times you got to hit shift mode to get to it. And you should have gotten 5040. 5040. So again, the second one is 10 factorial, and you'll see that it gets up there really quickly. This is what, 3,628,800 factorial. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is boring, but 3,628,000. Start getting up there, you know, if you play around with your calculator and you punch in like 88 factorial, your calculator may say overflow error or something. It depends on your calculator. Depends on how many digits you can go in scientific notation, because it's going to get up there very, very quickly. And if your calculator goes to 3 digits in scientific notation, you're good to go, but most only go to 2. 10 to the 99th, this is as high as it'll go. And so sometimes your calculator will say overflow error because the number doesn't fit. All right, so here's a permutation. There are 8 teams in a tournament. How many different ways can they finish first through third? So again, we're figuring out an order, right? First through third. Not just the top 3 teams, the order first through third. So it's a permutation. So the bottom left number would be what? 8. All right, got to think now. And the bottom right number is 3, because there's 3 items in the group. Now, I'm going to show you the formula. Almost everybody these days, their calculator has it in their calculator. But here's the formula. It's 8 factorial divided by 8 minus 3 factorial. So if you don't have the permutation button, though most of your calculators do, and almost all of them, but sometimes it's in a menu, and you don't know where the menu is, but it's there on your calculator. It looks just like that. Usually you punch in the left number, you hit the button, and then you punch in the right number. So usually you punch in 8, you hit your permutation button, you punch in 3, you hit enter, and it's going to give you the solution there of 8 teams And what is their finish, first through third? And you wouldn't believe this is possible, but there are 336 different ways you can have first through third with just 8 teams. And I say, no way. Yeah, 336 different ways 8 teams can end up first through third. Okay, so way more than you would think in a permutation. And again, what's the key in a permutation? The order matters. I want to show you one other little trick on permutations. So this is a little trick. Go ahead and do 101 factorial in your calculator. Just punch in 101 and hit the factorial button. Let me see your hand if your calculator gave you an answer. Anybody's calculator give you an answer? All right, so if you don't have the permutation button and you try to use the formula, you can't do the formula on this because you don't have 101 factorial possibility. However, a permutation works this way. If you'll start at that left number and you'll use the right number to tell you how many numbers to count down. So I go 101, that's the first, times 100, that's the second, times 99, that's the third, times 98, that's the fourth. That's the value of 101 items with 4 item groups. So just punch in 101 times 100 times 99 times 98. And what are we up to? 97,990,200. Somebody punch the permutation button and see if indeed you get the exact same value. Right? Did you punch it, right? Permutation button gives you the exact same value. This is, look, I don't know if you can comprehend this, but just real quickly, let me show you why this works. If you guys will look up at the screen. Remember, 101 factorial is 101 times, the top is that factorial, times 100, times 99, times 98, times 97 factorial, right? Luke, do you agree? Are you sure? It's not good to agree to something you have no idea what's going on. All right, so that's the top, right? 101 factorial. And the bottom is 101 minus 4 factorial, which indeed is 97 factorial. And you see how the 97 factorials divide out? And what do you end up with? 101 times 100 times 99 times 98. That's why that works. That's what's going on. That's the situation. But again, you have a button, so you can use your button. Any questions on permutations? So your brain has to say this: permutation, order. The order matters. All right, let's do combination. So combination is an arrangement of objects in no particular order. The order doesn't matter. So again, the left number is still the total number of objects available, and the right number is the number of objects in any group. Now, before we do that one, let me just mention something like this. If I had a combination 7-7, what do you think the answer to that's going to be? How many different groups of 7 objects can you make when you have 7 objects? How many different groups can you make? Just one. In a combination, whenever those numbers match, the answer is 1. Now, if it were a permutation, the order matters. You got a whole bunch of orders, 7 factorial. But a combination, whenever the two numbers match, the answer is 1. So again, combination, the formula, most prefer the formula of a permutation divided by 4 factorial, which is the same as 8 factorial divided by 8 minus 4 factorial times 4 factorial on the bottom. 8 factorial divided by 8 minus 4 factorial, that's the permutation, and then times the 4 factorial. But again, you have a button, right? You got a button, you got a button, you got a button. So punch in combination 8, 4, and see where it takes you. We got 8 items. We're doing them in 4 item groups. And if you found your button, you got 70, right? There's 70 different 4-member groups you can make with 8. I always like to do this last example when I do combinations. especially because I taught in Ohio for so long, and this is the Ohio Pick 6 lottery. And people would go crazy in Ohio like they do all over the place when these lotteries get to be really, really high. But I always like to show people the probability of them winning. So the Ohio Pick 6, you have to pick 6 numbers, and the order doesn't matter. The order of the numbers isn't a factor, just the correct 6 numbers. So go ahead and run the numbers for that permutation, and you'll figure out the probability of picking the winner. Somebody raise your hand when you get it. Come on, punch it in. Alex, what do you got? 15,820,700. Anybody know what the probability is of being struck by lightning? Anybody know? I think it's just over 1 million. How many of you personally know somebody struck by lightning? A couple of you. And you know a lot of people, right? And our world, our country these days is crazy in wasting their money in the lottery and just throwing their money away. What a shame, what a shame, what a shame, what a shame, what a shame. All right. Besides all the biblical implications, and by the way, there are many, and if you don't think there are, the answer is you haven't studied the subject out. Study the subject out, and you'll find out. All right, circular arrangements. Just always like to touch circular arrangements. The formula is very, very simple. It's just the total available around the circle minus 1, and it's that factorial. So the question is, you got a table here, you got 8 people around the table. How many different ways can the people sit around that table? How many different arrangements? And it just ends up being 7 factorial, right? 8 minus 1. And what was 7 factorial? We did it earlier. 5,040. You'd say no way. 5,040 different ways. Yeah, because each spot, is different. So that's the scenario. And with, if we call the top the head of the table, though it's round, I don't know if a round table has a head, but all 8 could sit in that top spot with, again, all the different arrangements, 5,040 different ways. So next time you're at a banquet, all right, see if you can execute all 5,040 ways around your circular table. It'll be fun. All right. In a weird math kind of way. Yeah. All right. So circular, that's all there is to those. Not a big deal. How about questions like this? Number of ways to row. Number of ways row. Number of ways to arrange repeat letter words. How many ways can you arrange repeat letter words? Well, it's pretty simplistic. If the word had no repeat letters, for example, how many ways can the letters in my first name, my first nickname, be rearranged? And this would simply be 4 factorial. I mean, there's no repeat letters, 4 factorial. But what if you have repeat letters? So then it's still n factorial, the number of letters, but then you divide by the bottom are the factorials of the repeat letters. I always like to do Mississippi, because everybody knows how to spell Mississippi, right? Even I can, who am not a very good speller, because we learned it, all right? It's memorized. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So n is 11. So it's 11 factorial. And then repeats. There are 4 i's. So 4 factorial. There are 4 s's. 4 factorial again. And there are 2 p's, so 2 factorial. No pod, though. Oh, well. That's the way it goes. 2 peas in a pod. All right, so go ahead and punch that out. Again, be careful in your calculator. Use a parentheses on the bottom or simply keep dividing by the bottom number. 11 factorial divided by 4 factorial divided by 4 factorial divided by 2 factorial. And voila, you'll figure out all the different ways you can arrange the letters. Are they all going to spell words? No. Obviously not. That's a whole nother ball game if you want to figure out words. You're going to have to write a pretty sophisticated program to do that. All right, so 34,650 different ways to arrange the letters. See, the repeat letters have a factor in it, right? I mean, obviously, you get an S in the front. All right, you got all the other possibilities with an S in the front, but there are 4 S's. So whether you put one of the other S's in front, it's still the same like that S is in the front, et cetera, all through the repeats. And it cuts down the number possible, right? We're reducing. We're dividing the number possible by 4 factorial, 4 factorial, 2 factorial, and we're reducing. All right, so if you're ever on Jeopardy and that trivia question comes up, you can now answer how many different ways to spell the word Mississippi. I'm sure you'll remember, and you'll be ready to roll. All right, last thing I want to do today, and this will take a little bit of time. It's hard to do this last one fast. The binomial expansion theorem. The binomial expansion theorem is a methodology for multiplying binomials. Okay? So that's the idea. It's simply a pattern that allows you to expand or multiply binomials. You will occasionally come up with a question like this on an ACT or SAT. It is possible. And so the binomial expansion theorem. All right, first off, we're going to understand it. N is the degree. N is the degree. And so I have a set of examples here. And so we're looking at the examples here and trying to figure out what we got. Okay, so N is the degree. And so in this situation, it's 0 degree. Do you guys remember? Anything divided by itself is 1. All right, you know what? I don't want my 1 there. Let's stick the 1 right here at like the top. Kind of in line right there up top. Beautiful. Stick our 1 right there. Beautiful. Okay. When n is 1, you have simply x plus y, right? Okay. What's the coefficient of the x? 1. What's the coefficient of the y? Let's put the 1s in. Say, Mr. Scarfrey, we usually don't write 1s. I know. I'm trying to show you a pattern. All right? Trying to show you a pattern. Okay, second, now we're down to an n of 2. And you have x plus y times x plus y. And here I'll do it below. You end up with x squared plus 2xy plus y squared. Trust me, if you multiplied it out, that's what you would get. So watch. Coefficient 1, right? Coefficient of the middle term 2. Coefficient of the outside term 1. Are you with me? Okay. What does the next one multiply out to? All right, so now you have 3 of them. X plus y times x plus y times x plus y. What do you get on this one? X cubed plus 3 x squared y plus 3 x y squared plus y cubed. So that's x cubed plus 3 x squared y plus 3 xy squared plus y cubed. Coefficients 1, 3, 3, 1. Okay. I'm going to stop multiplying out. I just want you to be aware of something. Okay, so here, let me do it this way. So look at the next row. N is 4. Do you agree? Right? N is 4, next row. Don't circle in your notes because it'll just make things confusing. I just want to focus your attention. Notice the front term is to the 4th power, right? It involves just the front variable, the x. Notice the next term, the x just went down 1, right? And the back y went from 0 to 1. Then x goes down 1 more from 3 to 2, and y goes up from 1 to 2. X goes down from 2 to 1, y goes up from 2 to 3. X goes down to 0, x to the 0 is 1, so we don't write it, and y is up to 4. See how the variables go? That's the pattern we're trying to learn. Do you see the coefficient pattern? Do you see the pattern with the numbers? What do you think the far left outside number is going to be? What do you think the far right outside number is going to be? It is. Those are correct. How about this second spot right here? Really? You know that, huh? It is a 4. How about this outside number right there? 4. And the middle number is a? No. Middle's not a 4. Say again?
Do you have markers that work over here?
I think so. You can take them all if you want. I have the others. That'll work. What's the middle number? I heard it. 6. The middle number is 6. The middle number is 6. Okay. So I don't want to go crazy with all the color, but let's do the last row. Okay, you got to start left here, and you got to write little. This is going to be an x to the 5th. Leave room for your coefficient, and then it's going to be an x to the 4th y, right? And I'll put to the 1st. And again, leave room for your coefficient. Then it's going to be x cubed y squared, right? And then it's going to be x squared y cubed. And then it's going to be x y to the 4th. And finally, outside is going to be y to the 5th. Do you see the pattern? All right. So anybody could do that because we can all, I hope we can all count. Oh, 5, 4, 3, 2, 1, 0, 1, 2. I feel like I sound like Bill Rice. 2, 3, 4, 5. All right. We're just counting. All right. So far left coefficient, 1. Far right coefficient, 1. All right. Second spot here on the left. It is a second one. I heard it. 5. It is a 5. You say, how? 1 plus 4 is 5. 1 plus 4 is 5. If you hadn't caught on yet. Let's do the second one on the right, this one right here. So that one is a 5 for the same reason. 1 plus 4 is a 5. Okay. I'm going to go, what about this one now in here? Third term coefficient is a, now we got it, right? So you guys said 4 and 6 is a 10, and the next one is a 10 because 6 and 4 is a 10. Now do you see how that 6 got in the middle there? Right? 3 and 3 is 6. Anybody know the name of the guy whose triangle this is Get rid of all the exponents. Just do the numbers. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You might know him from science. It is whose triangle? Begins with a P, as in written there. That's a P. You can't see that. I think I heard it. Pascal's? Maybe I didn't. All right. It's called Pascal's triangle. Look, can we keep going? You know the number's going to be 1, 6, 15, 20, 15, 6, 1, right? And on and on and on and on forever and ever. So if you want to do binomial expansion by Pascal's triangle, go ahead. You can. Now, if the coefficient's like 20, you're going to be writing a big triangle, but you could. All right? Pascal's triangle. Or we can use this pattern for binomial expansion. All the coefficients are combinations. Aha. Hence the tie-in to what we did earlier with combinations. So the coefficients are combinations. All right. So when you're understanding coefficients, we got to understand a couple things. First off, whenever the right-hand number is a 0, believe it or not, the answer is a 1. Now, far on the right, we've already discussed, whenever the two numbers match for a combination, the answer is 1. All right. So we got 1 there and we got 1 there. All right, so this one is 1. And then the other thing on a combination, when the right-hand number is 1, how many groups are there? 1, so how many combinations are there? Whoa. I'm backwards. When the right-hand number is 1, there are only one member in each group. So, for example, if you had 9, 1, how many groups can you make if you have 9 items and you're doing one-item groups? 9. So that one's N. Right? That one is N. So 1, N, and 1. Understanding that speeds things up. So therefore, if we were going to expand x plus y to the 4th, a combination 4, 0 is 1. A combination 4, 1 is 4. 4, 2, you're going to have to do that one combination-wise. So that one you're just going to have to figure out with a combination. Combination button tells you that is a 6. By the way, I didn't cover this one earlier. When these numbers are 1 apart, then again it's going to be 4. The n value, and the last number is a 1. So now we got all the coefficients. If you were going to expand something to the 4th power, x plus y to the 4th, first term is going to be a 1, second is going to be a 4, third is going to be a 6, fourth is going to be a 4, and the fifth is going to be a 1. One thing to know, let's suppose they stuck a minus in between the terms. Well, the first term is positive, and then all the other terms alternate. And you just have to do is alternate signs. All right, so let's see if we can expand x plus y to the 5th power. So hopefully you agree that n equals 5, right? Now, I don't know how you want to do it. I like to do my variables first. So the first variable is going to be, anybody know it? Come on, think now. You're doing an x plus y to the 5th. First variable is going to be what to what power? X to the 5th. All right. Plus sign, they're all going to be pluses because there's a plus. Leave some space for the coefficient. Next is going to come x to the fourth, y, right? Y to the first. And I'm just walking my way from 5. Next has to be x cubed, and the y goes up 1, the y squared. See, the first one had y to the 0. Then y to the first, y to the second. Now I'm at x squared, y cubed. Then I'm at x, y to the fourth. And finally, I'm at y to the fifth. Pattern. It's just a pattern. All right, so remember now, how do the combinations go? And I'm going to do this up above so you guys get the idea. So the combination of the first term is a 5, right? N value with a 0. And now again, the 5 goes down and the 0 goes up. So the next one is 4 1, 5 1. Yeah, I'm sorry. The N stays and the other one goes up. 5 1, 5 2, 5 3, 5 4. Oh, 5 5 4. Going fast. 5 4 and 5 5. So the N stays, the 5, and the right number goes up 0, 1, 2, 3, 4, 5. So you know the front coefficient is 1. You know the last coefficient of 5 5 is 1. What's a 5 1? What do you get with a 5 1? A 5, right? Go second to the last on the right. And again, you can punch your combination button, but what do you get with a 5 4? If these are 1 apart, you get a 5 again. Now the rest you got to use your button, your calculator. So do a 5 2 in your calculator, and then do a 5 3 in your calculator, and both of those are 10. There it is. Quantity x plus 5, or x plus y times x plus y times x plus y times x plus y times x plus y. Isn't that exciting? That's awesome. It's amazing. It's remarkable. It slices and dices and does it all for $19.95. It's great. And we'll send you a bonus one. Just pay additional shipping and handling, which is as much as the item. All right, but so here's 1 to the 6th, and that one's interesting, but let's get right to the cut to the chase. Let's do that last 1 to the 7th power. All right, this one's interesting because of this situation. The front term is a 2n. Ooh, you mean we can do these if they're not just like xy? Yeah. Yeah. We can. Kayla, your brain gonna hold up? All right. You know, you scared me on that first page of that second part. Then did you miss any more on that? One more maybe on that second half? No. All right. She missed all 3 on that first page. I'm like, oh no, Kayla, bad brain day, but she recovered. Because you were perfect on the first half, weren't you? You were. All right. So anyhow, 2n. Look, here's how we're going to start. What's the exponent going to be? First term. 7. So watch, you have 2n to the 7th. That's all. That's the adjustment. You might say, what do you mean that's all? Well, that's all, kind of. And the next term, notice the parentheses, 2n to the 6th, z, right, to the first? Here, I'll go higher for you guys. I was trying to leave the pattern up there, but I'll go higher for you. So the next is going to be 2n to the 5th, z squared, right? We're just counting down. We can count. You can count. 2n to the 4th, z cubed. I'm getting smaller and smaller, aren't I? Because I know I got to fit this in. 2n cubed, z to the fourth. 2n squared, z to the fifth. 2n z to the sixth. Don't need your parentheses, right? 2n to the first. And then finally, hooray, we're there. Sticking all my little plus signs here. Z to the seventh. And look, now by the way, you got to factor in these 2's, right? Ultimately for the coefficient. But the pattern is going to be a combination of what? What's the bottom left number? Come on, talk to me. Bottom left number. Bottom left number. 7. And right is 0, right? Now, can you count from here? I think you can. 7, 1, 7, 2, 7, 3, 7, 4, 7, 5, 7, 6, 7, 7. So, by the way, this first one is a 1. And this is a 7. And next is a 21. And next is a 35. And next is a 21. And next is a, did I skip something? 2 35s, I'm sorry. 35, 35. 21, 7, and 1. Now, are we done? You'd have to clean up 2 to the 7th, which happens to be 128. So I'll have to end here. This is 128, n to the 7th. And you do that all the way across. Cool. All right, have a great day. That was certainly better than a study hall, wasn't it?